Thank you. Well, first, let me say it's a pleasure to be able to make a presentation today on one of the key issues of facing the world, and that is human-induced climate change. The next slide actually says that effectively there's not just one major environmental issue, there's really four as a minimum. There's climate change, loss of biodiversity, degradation of nature, land degradation, air and water pollution. And all of these four are interconnected, and all of these four will threaten and are threatening human well-being of both current and future generations. I will primarily focus my talk on climate change, but throughout the talk, I'll show interconnections with these other three big issues. The next slide, next slide actually shows the interconnections, and that is you can't think of climate change without thinking of loss of biodiversity. They're interrelated. You can't think of climate change without land degradation. So land degradation, loss of biodiversity, both affect climate change. Equally, if one's looking at biodiversity, it's affected by climate change, and I'll touch upon that in my talk, and it's also affected by land degradation, etc. All three of these issues all actually impact on human well-being. They impact on the big development challenges we've got, feeding the world, providing clean water for everybody. And so one of the key points of my talk is we have conventions on climate change, on loss of biodiversity, on land degradation, and we have 17 sustainable development goals. What we need are harmonized goals, targets, and action among these conventions and the SDGs. The next slide moves us on to saying, well, why effectively, what's the issue? Well, effectively, I've already said, these issues affect human well-being. They are economic issues. They affect the economy of the world. They're development issues. They undermine, as I've already said, issues such as poverty, hunger, access to clean water. They're security issues. They cause local conflicts in many parts of the world, and they're social, moral, and ethical issues. It's we, the industrialized world, that's caused most of the climate change, caused most of the loss of our biodiversity, and therefore there are moral and ethical issues embedded here. The next slide shows what I call the wedding cake. On the bottom level, we have climate and we have biodiversity, three of the SDGs. If we don't get to grips with these particular issues, we're not going to be able to solve the problems of the world. They undermine the sustainability of our cities. They undermine food and water security. And indeed, if we do undermine the production and consumption of things like agriculture, food, water, energy, then overall, they undermine our ability to have good human health for everybody. They undermine our ability to address poverty, the inequities in the world today. And so this is why I say climate change and biodiversity are not simply environmental issues. They are central to achieving the SDGs. The next slide says, okay, what are the underlying causes of environmental degradation? Well, over the last 50 years, the global economy has grown nearly fivefold. World population has doubled. It's now over 7.5 billion people, and international trade has grown tenfold. This increase in the number of people, the increase in their individual and collective wealth, means an ever-increasing demand for energy, food, fiber, materials, and medicines. This actually puts pressure on the environment, especially the way we're actually producing our energy, food, fiber, and materials. Now, it's important to note that while overall there's been an increase in prosperity across the world, and the average prosperity has actually doubled in the last 50 years, there's still over 1 billion people remain poor and about 700 million hungry. We clearly have an inequitable world. And indeed, that number of 700 million hungry has probably gone up by another 100 million due to the last 18 months due to COVID. The next slide I said, I know, we'll talk about climate. So the next slide. Okay, where are we? Well, there's no doubt the Earth's climate is changing, and it's going to change even more in the future. We're already about 1.2 degrees Celsius warmer than the pre-industrial period, 1850. Most of that warming has actually been in the last 50 years. We're seeing major changes in rainfall. The wet areas typically are getting wetter. That's the tropic and the high latitudes. And the subtropics, are getting drier. We'll see far more heavy rainfall periods and longer spells with light precipitation. What does that mean? In the same geographic location, we're going to see more floods and more droughts. We're also seeing more heat waves. Hurricanes and cyclones are becoming more frequent, and in some parts of the world, more severe. Sea level is rising at an unsustainable and increasing rate, and the cryosphere is melting. Arctic sea ice drastically reduced relative to 10, 20 years ago. Mountain glaciers in all parts of the world are retreating, and parts of the Greenland ice sheet and Antarctica are also melting. The next slide. Then actually, and there's probably a lot of students watching this. What if you were born in the year 2000? Typical university student. Well, the world had already warmed by 0.75 degrees Celsius when you were born. Where are we today? As I've already said, you're 20 years old. It's 1.1 to 1.2 degrees Celsius warmer than pre-industrial. By the time you're 40, it'll be 1.7 to 2 degrees Celsius. By the time you're 60, it'll be 2.2 to 2.9 degrees Celsius warmer. And by the time you're 80, potentially 2.6 to 4.3. And if you're lucky enough to live to 100, it'll be 2.9 to 5.3. So in other words, the world is going to warm significantly during your lifetime. The next slide. On the left-hand side, it shows what's happened over the last 2,000 years. And you can see the lines wiggling just above zero, and then it goes below zero around 1600, and then it shoots up in the last little period, 1850 to 2000. Most, as I've said, in the last 50 years. So clearly, for most of the last 2,000 years, the Earth's temperature had been relatively constant, plus or minus 0.1, 0.2, 0.3 degrees Celsius. On the right-hand side, in the black line, where it's superimposed on an orange color, the one that is continuous and wiggly, they're the Earth observations. That's sea and land-based observations, 30,000 observations every day around the globe. And as you can see, it's gone up considerably, especially since 1950. Right below there is a continuous line, hard to see, unfortunately, but that's a climate model that takes into account changes in greenhouse gases, aerosols, land albedo, and natural phenomena. Changes in solar activity, changes in volcanic activity. And it's a pretty good simulation of what we've observed of changes in global mean surface temperature. At the very bottom in blue, that's a climate model that only simulates changes in solar activity and volcanic activity. And as you can see, it does not simulate the observations at all. The next slide moves on effectively to a global perspective. At the very top, these were the observed changes when it was 1 degree Celsius global average. And on the right at the top is a simulated three-dimensional climate model using the same parameters I've just talked about. As you can see, the simulation is very, very good and simulates our observed changes. The land warms more than the ocean, and the high latitudes warm more than the equatorial region. On the bottom, we simulated what would a world look like for temperature increases with a global average of 1.5, 2, and 4. And especially when you get to 4 degrees Celsius, which we can't totally rule out at the moment, you really can see the differences between land and ocean, and high latitudes in the equatorial region. And in the high latitudes, you could see temperatures of 6, 7, 8 degrees Celsius. The next slide shows precipitation. And on the top, it shows 1.5 degrees Celsius world, a 2 degree in the middle, and a 4 degree on the right. The message is very simple. The equatorial region and the high latitudes are getting wetter. That's shown in green. Those areas that you see in brown and yellow, they're the areas becoming drier. So it is this perverse situation. The wet areas of the world are getting wetter, the dry areas are getting drier. One thing to notice in particular is Southern Europe, the Mediterranean area, southern Spain, Portugal, France, Greece, Italy, all getting significantly drier. Major threats to agriculture in those areas of the world. The next slide then moves us on to talking about what's causing the changes. Well, very straightforward. It's an increase in the abundance of greenhouse gases in the atmosphere. They act as a blanket around the world. The key gases are carbon dioxide. It's burnt when we burn coal, oil, and gas for electricity, for transportation. It also occurs when we cut down our forests, tropical deforestation. Of course, in Europe and North America, we cut most of our forests down more than 100 years ago. But now, unfortunately, major tropical deforestation contributes between 10 and 20% to greenhouse gas emissions. But also methane and nitrous oxide are important greenhouse gases. Methane, it actually comes from leaking oil pipelines, but also from agriculture, rice production, ruminant animals. Nitrous oxide also comes from agriculture, predominantly use of fertilizers. The next slide, please, actually shows what's happened to energy demand over the last, well, it goes all the way back to 1800. But the key point is to note from 1960, we have actually tripled our use of energy in the last 50 years. And this is responsible for about 75% of the greenhouse gases. The next slide says we've changed land use. And what we've 3/4 of the ice-free land has been converted. 1/4 of that radically converted into cities, into roads. But also we've cut down our forests, converted our mangrove swamps, converted our grasslands into agriculture, often monoculture agriculture, into plantation forests, all contributing to greenhouse gas emissions and loss of biodiversity. And we project by 2050, only 10% of the ice-free land will be anything close to near natural. The next slide moves us on, I believe, yet to greenhouse gases. And as you can see, from 1990 till 2019, significant increase in all of the greenhouse gases. Fossil CO2 at the bottom in blue is the most important, followed by methane, followed by a small amount of fluorinated gases, and then land use change contributing to carbon dioxide, methane, and nitrous oxide. The next slide says, well, the future of the world is in our hands. It depends what socio-economic pathway we choose. If we actually choose a more sustainable pathway, SSP1, we could actually move to a more sustainable world. We would need policies that are actively moving us to sustainable production and use of resources. We need international cooperation between developed and developing countries and between them. We want to have low growth in material consumption, possibly more use of low meat diets, more vegetables, more fruits. We want to reduce the inequality in the world. As I said at the beginning, we have a highly unequal world, low population growth, but relatively high per capita economic growth. They're the characteristics of a more sustainable world. In the middle, it's business as usual. We trundle along as we are today. We really don't take issues such as climate, biodiversity loss, into account adequately. And on the top right-hand corner, SSP3, a very unequal world. We don't really care about sustainability. We talk about national security. We have barriers to trade like we've got now. We're highly intense in our material consumption. We don't try and deal with an inequitable world. We do have relatively population growth, but we also have slow economic growth. So you can have a more equitable world, and you can have, on the others, far more inequitable worlds and ones that are not at all sustainable. So the next slide simply says, what would happen to greenhouse gas emissions and temperature in those 5 worlds? So the sustainable world, the one that you had in the bottom left-hand corner, very, very low emissions of greenhouse gases. Then you go to low, intermediate, high, and very high. The one in the top right leads to very high emissions. Well, by 2030, 2021 to 2040, the emissions do go up from the low emissions to the high, 30 to 51 gigatons per year. Temperature probably not affected very much on the emissions scenario between now. It's only 8 years away. By the time you get to the mid-century, 2041, 2060, big changes in greenhouse gas emissions. Only 3 in a very low emission scenario, 82 in a very high emission scenario. And now you see differences in temperature, 1.6 in low to 2.4 in very high. By the time you get to the end of the century, 2080, 2100, in the 2 low scenarios, you've got negative emissions, -10, -8. But in a high emission scenario, which you can't totally rule out, not likely, but can't be ruled out, 130 gigatons. And now you really see changes in temperature, 1.4 for very low, 1.8 low, all the way up to 4.4 for the very high. The next slide shows you it schematically. So the top just shows you the evolution of global mean surface temperature over the next 80 years. Below, that's Arctic sea ice. The warmer that we become, the more loss of Arctic sea ice. The next one is ocean surface pH, the acidity of the ocean. The higher the emissions of carbon dioxide, the more the oceans absorb carbon dioxide, the more they become acidic. And the bottom one is, the more we warm the world, the more we're going to see increases in sea level, anywhere from 0.5 to 1 meter by 2100. But we can't rule out even a couple of meters if the Greenland ice sheet and the West Antarctica ice sheet melt faster than we currently think from our models. On the right, it just shows projected changes in sea level for 2300. And here you can see some massive changes in sea level. Even in the low emission scenario, it's anywhere from 0.5 meter to 3. And in the high emission scenario, 2 to 7. The next slide, please. This simply says, and I'm not going to go in detail, we're going to see far more frequency of extreme weather. Once when you had a severe heat wave, the 1 in 10 year cycle, if we allow the global mean surface temperature to warm 4 degrees, we're actually going to get them every year, not once in 10 years. And the 1 in 50 year event would almost become a 1 in 1 year event with a 5-degree warming. And we're going to see more extreme precipitation of it. So extreme events are going to become more frequent. The next slide, please. Says, okay, what are the implications? And I've really said this: adverse effect on food security, water security, adverse effects on human health, vector-borne diseases such as malaria, dengue, waterborne diseases such as cholera, heat stress mortality, deaths from extreme weather events, lack of nutritious food. We're going to see potentially hundreds of millions of people displaced either temporarily or permanently due to sea level rise and inland flooding, and adverse effects on nature. The next slide. This just shows you the 5 big threats to biodiversity. Land and sea use change in purple, direct exploitation in pink, climate change in yellow, pollution in green, invasive alien species in blue. Now, while climate change has not been the dominant threat to biodiversity in the last 50 years, if we don't meet the Paris targets, it may become the dominant threat. 1 million of the 8 million animals and plants are threatened with extinction. Population sizes and abundances are decreasing, and our ecosystems are being degraded. The next slide simply shows you that many terrestrial systems, dry land water, vegetation, permafrost, and food are all threatened. Each histogram shows you in white, colorless, not a threat. Amber shows a medium threat, red shows a high threat, and purple a very high threat. And you can see literally all of these systems are threatened, at least to the medium, if not a high level of threat, once you get to 2 degrees Celsius. And we're definitely on a pathway to at least 2 degrees Celsius. The next slide shows the equivalent of shows what happens to insects, birds, mammals, and plants. They all have what they call a climatically determined geographic range. At 1.5 degrees Celsius, there would be 5% of insects lose half of their geographically determined range. But if we go to 4.5 degrees Celsius, we'd lose almost 70% of insects would lose half of their climatically determined range. And you see something similar for birds, mammals, and plants. What you can see is climate change temperature, a major threat to insects, birds, mammals, and plants. Next slide shows what happens to ocean systems. Very similar to the terrestrial system. Warm water corals on the left. We've already lost half of warm water corals around the world. And at a 2 degrees Celsius rise, we would lose 99% of all warm water corals. The next slide. And I'm running behind schedule and I apologize. We need to stop using fossil fuels. We need to use our energy more efficiently. We need to stop deforestation. We need sustainable agricultural practices. We need to eliminate subsidies on fossil fuel and transportation and encourage the use, and therefore all of these inhibit the use of clean energy. We need to use that money that we spend on fossil fuel subsidies on clean energy. The next slide says, well, all the governments in the world agreed to try and limit climate change to less than 2 Celsius and preferably 1.5. Unfortunately, the pledges made in Paris put us on a pathway to 3 to 4, not 1.5 to 2. If we want to meet the Paris target, we need a 50% reduction in current emissions by 2030 and meet net zero emissions by mid-century, and of course reduce the emissions of other greenhouse gases. The next slide simply shows schematically what you have to do, and the bottom line here is the Paris pledges were while you need to reduce by 50% relative to today, with the Paris pledges, the emissions in 2030 would be slightly above, not below, current emissions. Clearly, that puts us on a pathway, as I've already said, 3 to 4. The next slide says the Paris Agreement is a good agreement. Unfortunately, we'll probably pass 1.5 degrees Celsius by the mid-2030s and pass 2 degrees Celsius by 2050, 2060. The next slide simply says COP26, in my opinion, largely a failure. They focus too much on being net zero by the middle of the century, when what we really must focus on is reductions in emissions between now and 2030. 40 countries did sign a pledge to phase out coal, but the 4 biggest producers and users, China, India, US, and Australia, refused to sign. The 2 biggest first and third emitters, China and India, they say they can't reduce their emissions. They will peak their emissions by 2030. And I'm not convinced President Biden can actually live up to his promise of a 50-60% reduction in American emissions by 2030. They did agree to reduce methane, which is good, but they're behind on providing financing to developing countries to adapt and mitigate climate change. But they did talk about trying to eliminate deforestation by 2030. Next slide. So what we can do, and I'm going to actually finish on this, even though it's not my last slide, I'm behind schedule. We can use our ingenuity, our technology and our cooperation. We can transform our economies and have a sustainable world. It will need a fundamental change in our technological, economic and social organization of society. We will have to rethink our norms, our values, our governance structures. Major changes are needed in the economic system. We need to value nature. We need to eliminate subsidies. We need to internalize externalities in the prices of our goods. In other words, we need to put a price on pollution, and we need sustainable consumption and production. And effectively, we need to overcome the inertia and the opposition of vested interest. There are many in society that like cheap energy, unsustainable agricultural practices. We have to overcome those vested interests. And the economic recovery packages from COVID could give us the impetus to accelerate to transformative change. But to be honest, most of those economic packages are not green enough. And lastly, my comment is we need everybody to act. Government, business, financial systems, individuals, NGOs, and the science and educational communities. Thank you.
Thank you very much, Bob. That was a fantastic overview, and I guess a little bit of a reality check as well at the same time. So just if anyone has a question, feel free to post it in the chat and we can get to it. I'm going to kick us off, Bob, and it kind of relates, I guess, to a little bit to COP and a little bit to COVID as well. So, you know, people spoke a lot about the Great Reset and, you know, the sort of building back better, to quote a certain political party's slogan, after COVID. Have we grasped that opportunity, or have we let it slip through our fingers, do you think?
I think it depends on where. I think the European Union has tried to grasp it. I don't have all the details, but I do believe the European Union are convinced they can use the economic recovery packages to green their economy. Low carbon, restoration, conservation of biodiversity. In the infrastructure bill of the US, there is money to address climate change. Probably not enough, but a major step in the right direction. But I think many of the other recovery packages just aren't adequate. And actually, to be honest, since COP26, only a couple of weeks ago in Glasgow, India and China have asked their coal mines to increase production because of scarcity of energy. Biden has asked the oil and gas companies in America to increase the production of oil and gas because energy prices have gone to an all-time high. So the three biggest emitters of greenhouse gases, India, China, and the US, have all going in the wrong direction. They all say this is short-term, but it will not put us on a path to the Paris targets and not put us on a path to net zero by 2050.
Okay. Well, that's as one of our attendees said here today, that we think we need to get you to repeat this talk in a newsroom as well as scientific conference. I'm going to just there's one question here from Sean Troy, which I believe I can put up on the screen there. So Sean's question was, what percentage of the solution will be policy versus market based?
It will clearly be both. Governments have to put in place the policies that will stimulate a transition to a green economy. They need to effectively put hard targets. And so if indeed they place hard targets and then they put the right financing mechanisms and policies, that will stimulate market-based approaches. The market alone will almost certainly not get us there, basically. The fossil fuels are just too cheap, although I should note that wind energy and solar energy are becoming actually cheaper than new fossil fuel plants in many parts of the world. So the market is moving us in the right direction. The price of solar energy has come down by more than a factor of 10 in the last 10, 15 years. Wind power is coming down. But the trouble we see is there's still some opposition from the public of windmills on land. And so clearly, in many cases, we're now doing windmills out, offshore, basically. So even though the public want us to address climate change, they often don't want to embrace higher energy prices or things like windmill farms on land. So I think it will be we need the government and the private sector and financial organizations all to work together in partnership, basically.
That's a great answer, Bob, and I think it actually segues really nicely into our final question, which is actually from our director, but has been posted into the main chat from our CEO Jennifer Craig. So it's a question about, clearly science is critical, and would you agree if physical science and engineering needs to be combined with social science, so really understanding society to make real progress?
No question whatsoever. Absolutely. There's so many. We know enough to act on both climate change and biodiversity, but there's still, where can we store carbon dioxide? Where is the best place to site windmills? And in every question, it's not just technology or natural sciences, that social sciences, the humanities have a major role to play here. And I think that was a mistake too many governments, funding organizations made. We focused on the natural sciences. We focus on technology, incredibly important, both of them. Geosciences, absolutely critical. We underestimated the importance of social sciences and the humanities. And I think we're moving in the right direction now. Most of the assessments are indeed transdisciplinary. We all need to work together. We cannot solve this with technology. Behavior change is absolutely critical to go along with technology change and policy change.
Yeah, and I think some of the work that we have planned in ICRAG too, that interdisciplinarity between engineering, physical science and social science should hopefully make a real difference there. Okay, Bob, listen, we're out of time. Thank you so much for giving your expertise and your wisdom and your thoughts here today. Thank you so much for joining us for ICRAG 2021, and we wish you all the best. Thank you very much, Bob.
Thank you.